Okay, hope everyone enjoyed the beautiful poster session in the Green Woods and lunch. We're going to start the afternoon session for AKBC second day. It's my delight to introduce Professor Stephan Lewandowsky at the University of Bristol. He's coming from a little bit different background than us. He's a cognitive scientist and has been working on understanding how people respond to misinformation, propaganda, and so forth. And he's gonna today talk about how to build taxonomy for understanding anti-vaccination arguments. So floor is yours.
Okay, thanks so much. Are these live? Can you hear me? Okay, good. Hard for me to tell whether these are actually picking me up. All right, wonderful. What I want to do today is tell you about the JitsuVax project. Why is it called JitsuVax? Well, because we're playing jiu-jitsu with misinformation. That is, we're relying on misinformation in order to teach healthcare professionals and the public something about vaccinations. And as you can see from this little map, we're spread all over Europe and including a node in Canada, which is not in Europe, but it's part of our team. And these are the co-authors of the particular work I want to talk about today, with Angelo taking the lead on this. And we have some very hardcore machine learning people from Darmstadt on the team, whom I will give all the credit for anything that's of interest today, and I will take all the blame for misrepresenting them. Now, the context of the project is vaccinations, people's attitudes about vaccinations, and in particular, pleasingly or gratifyingly, Europe has become far more pro-vaccine for COVID-19 after the rollout commenced. At the beginning, before the vaccines became available, really, some countries were very, very low in their willingness to get vaccinated against COVID-19, but then over time, within less than a year, that changed considerably, and we're now, exceeding 80% in most European countries. But 80% is not 100%, and the difference is the share of unvaccinated people, and among those, there's some evidence that their anti-vaccination attitudes are hardening. These are data from last October, about a year ago, and you can find that, in the German-speaking countries, more than 20% of people still hadn't been vaccinated. Now, of those who were surveyed at the time, about 2/3 said, there's no way I'll ever get vaccinated. Another quarter said, probably not. And only 10% of those at the time were undecided. Oh, and yes, surprise, surprise, half of them vote for the extreme right. Now, 8 months later, in June, the actual uptake data mirror those survey responses almost precisely. In other words, it's only about 10% of those that hadn't been vaccinated that by June finally got their shots. So the survey data translate into actual behavior. So given how important it is to raise vaccination rates in order to deal not just with this pandemic, but with any infectious disease where you have to have a high vaccination level in order to achieve herd immunity, given how important that is, we need to understand where this hesitancy is coming from. Now, the approach we're taking in our project is to conceptualize something we call attitude roots. And those are the sort of deeply held beliefs or identity issues, attitudes, personal ideologies that are motivating a person to reject the scientific consensus, either on vaccinations or climate change or whatever other issue, where their attitude roots are in conflict with the scientific evidence. So the objective of the project I want to tell you about today, which is a tiny part of JitsuVax, is to identify attitude roots different attitude roots by analyzing anti-vaccination arguments and to create a taxonomy based on that analysis, which in turn then allows us to develop countermeasures, that is, communication tools that can help communicate the scientific evidence in a manner that is consonant with a person's attitude. And so the main focus for today is on creating this taxonomy, which we did by conducting 2 studies. By study now, I don't mean an experiment, I don't mean behavioral data, I mean a conceptual exercise, in this case a systematic literature review, where what we looked at was decades of research on anti-vaccination argumentation by other scholars. So the search string, as you can see, sort of picked up, vaccination refusal, anti-vax, anti-vax with an X, vaccination opponents, skeptics, etc., 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 combined with argument theme rhetoric to pick up any scholarly analysis dealing with anti-vaccination rhetoric. And following the usual PRISMA guidelines for a systematic review, we excluded some papers that were irrelevant and so on and so on. We ended up with 152 studies in our body of literature from all around the world and spanning, whatever that is, about 50-something years between 1967 and 2021. Now, most of the methods of the studies we reviewed were qualitative or mixed. There were few quantitative papers among them. Because this spanned such a long time preceding the pandemic, only a small share of the papers dealt with COVID-19, and the vast majority dealt with HPV, influenza, or just a multiple range of vaccines. So that's the corpus of literature that we looked at. And we now went through that for reviewers independently, examined the arguments that were reported in that literature as having been made by people who oppose vaccination. So these are not the arguments of the authors. These are the arguments made by opponents of vaccination that the authors analyzed or discussed in their papers. And so here's an example of how we identify a root of an argument. So, for example, if somebody opposing vaccines, the HPV vaccine, this is against cervical cancer, and it's politically controversial because cervical cancer is transmitted through sexual activity. And so if you vaccinate young women or teenagers, then of course that can cause political problems with the parents who may say, oh, this just encourages unsafe sex. So we then identify as a root, in this case, sexual promiscuity as the overarching theme, and we consider that to be a moral concern. And by going through all these arguments in the literature and resolving disagreements, we took the 2,000-something arguments we found and classified them into 62 themes that were nestled within 11 different roots. So we have a hierarchical taxonomy of arguments. And here are the 11 roots. Now, if you wonder where they came from, the answer is based on prior knowledge of attitudes that are driving vaccine hesitancy, number one. So, for example, there's a large amount of evidence suggesting that a lot of anti-vaccine sentiments arise from a person's tendency to believe in conspiracy theories. That's been known for many, many years. It's a hugely strong predictor empirically. So that was something we knew ahead of time. But then some of the other concerns emerged through our analysis. So, for example, perceived self-interest would refer to a person who's saying, well, if everybody else is vaccinated, why should I get vaccinated? Because I can free ride on everybody else. Now, that's totally true, by the way, but of course it is, it is something that reflects perceived self-interest. And reactance, that may also be a word not widely known outside psychology, refers basically to people saying, don't you dare tell me what to do. Okay, anybody ever said that's reactance? If you make the suggestion you might wear a seatbelt to stay alive, and the answer is don't you tell me what to do, you snowflake, or whatever, then that is an instance of reactance. So here are those roots. Here's the distribution of those roots in the corpus. They're not evenly distributed. There are three winners. Distrust, fears and phobias. People are afraid of vaccines. Very often also people are afraid of needles. That is not uncommon, and fear of needles is actually a major barrier to vaccinations. And the third category being unwarranted beliefs. By that we mean beliefs for which there is no scientific evidence, such as the belief that homeopathy will take care of COVID and you don't need to be vaccinated. And then within these roots, we have 62 themes. I'm illustrating some of them here. So within the conspiracies, you have a government cover-up, big pharma, population control. You can imagine if you've ever been on the internet and listened to people talk about COVID-19, some of those will be familiar. Within epistemic relativism, you have this meme that, oh, truth is relative. It just depends on your perspective. And for me, homeopathy works, so I'm not interested in medicine, anecdotal, et cetera, et cetera. So these are all the themes that are out there and that we identified. So just to illustrate what this looks like, I've just put up some word clouds for two roots, one involving unwarranted beliefs, the other one worldview and politics. And what you get is basically what you'd expect. Natural immunity pops out of the unwarranted beliefs cluster, government, power, authorities, the state, all these other buzzwords pop out of the worldview and politics cluster. Now, it turns out these word clouds become relevant later on when we get into the machine learning aspect of this project. So, that was our first study. The second study was similar, but looked at a completely different corpus of misinformation. Namely, it looked at a corpus of misinformation about COVID that was debunked. So this is a collection of corrections and rebuttals and debunks of misinformation. We filtered out all the stuff that related to vaccines, because that's the only thing we're interested in at the moment. And so we ended up, at the time when we did this, with nearly 600 myths about COVID-19 vaccinations that were rebutted or debunked by fact checkers. And we then did a similar process whereby we independently assigned each headline claim to attitude roots. We resolved discrepancies and so on until we were comfortable with our assignment of claims to roots. And if you now compare that second study to the first study in terms of just the frequency distribution of the different roots, where blue is study 1 and red is study 2, the fact-checked myths, then you find that the distribution is very similar. And the winners are, as before, fears and phobias, distrust, unwarranted beliefs. So that by itself is kind of interesting that at a course level at least, there is a striking similarity in the distribution of different attitude roots between 50 years of scientific literature and COVID-19 misinformation. Nothing ever changes in, the anti-vax vocabulary. And indeed, that is true. A lot of the memes about COVID-19 vaccines also came along with, MMR and any other vaccine. So now that's, in a sense, background. Now I want to turn to topic modeling, to natural language processing, which I suppose for this audience is of greater interest. But that topic modeling is going to rely on the two corpora that I just presented. So let's compare study 1 and study 2. And just to remind you, study 1 was a systematic review. Study 2 was a collection of debunked misinformation collected by other people. We didn't collect that. We just went to the website run by a consortium of fact checkers and chose the information from there. Now, they're considerably different because the first study deals with arguments being analyzed by scholars, and this deals with fact checks being analyzed or being rebutted by fact checkers. Now, in both cases, the assignment to roots was done by humans, which is okay. And in fact, to be honest, it's the same humans. It's the team of authors that did it for both studies. But now, what we'd like to do is to see if we can formalize that a little bit more or do some confirmatory analysis using text modeling of maybe each study in isolation, but maybe also both together. And as it turns out, we did all of the above. We modeled each study, and we also modeled them both together, and it's the latter that I've found particularly interesting. Now, we did this in two different ways. The first way, using LDA, latent Dirichlet allocation, is terribly unsophisticated by contemporary standards. I'm well aware of that. However, it was an interesting and easy to explain start. So what you do with LDA, just to refresh your memory, is to run it on a corpus of documents. Each document has words in it. And the analysis assigns each word to a topic with some parameter beta, and each topic that is being identified to documents with another parameter called gamma. And the point is that if you do this on one corpus, ideally that model can generalize to new documents. And that is precisely what we examined in this case. So just to illustrate how this works, this is one example by Bly et al. From, I think, 2003, where they looked at a corpus of AP, Associated Press, news articles. And what the analysis did was to identify lots of topics, among them those four here. And I'm showing you the words that were assigned to each topic with this highest value of parameter beta. Now, what's interesting here is that the labels are inferred by the researcher. The analysis does not give you labels. It just gives you, takes a bag of words and turns it into smaller bags of words and puts together all the ones that it thinks fit together. And then you can look at each document and identify the topics represented by this document by simply counting the number of words of each color. By color, I now mean the topics at the top. And then you can say, oh, well, this one is about budgets. because it's green. Oh, and it's also about education because it's red, and so on. And you formalize that by the parameter gamma. So we did that, except we took it one step further because we used something called seeded LDA. So what we did was the following. We took the information from study 1, basically the word clouds for each root. That is all the arguments that we classified or assigned to each root. We threw them all together, created a bag of words, counted the frequency, and we then used the top words here to seed LDA on study 2. Now, LDA on study 2 did exactly what I just explained in the context of the AP model or AP analysis, but what we did then was to try and get the machine to predict the roots that we assigned in without knowledge of those roots. So, how did this work? Well, here are the details of precisely how we did it. We took the top 8 words of each attitude in study 1. We used them as seeds. We then did the LDA on the full text of debunkings or rebuttals in study 2. Now, the whole point of a seeded LDA is that the LDA is given the names of the topics and the number of topics up front, and it is given some words within that topic, and it then uses its own analysis to take the other 134,000 words and assign them to topics, balancing what it is finding in the corpus with the seeds it is being given. And once it's done that, we can then identify which root a rebuttal should be assigned to based on which is the predominant topic captured by this parameter gamma for each document, that is for each of those 600 odd rebuttals. And that actually worked, kind of. We identified the root that was assigned by humans correctly 15% of the time. Chance is 9%. If we look at the top 2 accuracy, so if we say, well, if the top 2 topics are, if either one of them is the right one, then we give the machine credit for this. That raises accuracy to 31%, which is, reasonably above chance. So what can we say now at this juncture? Well, what we can say is statistically, yes, we detected a signal. And in fact, we were able to analyze the corpus of fact checks and predict the roots that humans assign to that with above chance accuracy. And we can do this with the assistance of seeding from study 1. Now, that is actually remarkable if you consider how different the 2 corpora are. And this was mainly an exercise of seeing whether there is a signal between 50 years of academic research and vaccines other than COVID-19 and a 1-year collection of misinformation and the rebuttal to that misinformation that had been classified by humans on the basis of the headline only, okay? So by the time you work out how different this is and how different the humans operated from the machine, I think that performance was actually quite okay. Not overwhelming, but the fact that there is a signal is pretty cool. And then, of course, we took a, time travel and advanced from historical LDA to contemporary methodologies and used transformer-based modeling. Now, so what we did was to take a pre-trained transformer this is just a cartoon version of what that is. Just to remind you, this is a machine that is pre-trained in converting text into context-sensitive vector representations on a huge corpus of stuff, like books, Wikipedia, and who knows what else. Massive amounts of learning, but we don't do that. Somebody else has done that. You then download the resulting machine, the model, and you can then run your own text through that model to get these context-sensitive vector representations. Okay, now that's a sort of a thumbnail, poor man's sketch of what is going on, but I hope it is sufficient to, you probably know this stuff better than I do, to refresh your memory of what's going on. So, we then use the sentence transformer model on study 1. Remember, that's the literature, the systematic review of the literature. And we basically did nothing other than to run that corpus through the transformer model without any further supervision. All we did was to apply UMAP, which is a dimension reduction algorithm that is just compressing everything into 3 dimensions so you can plot it, turn it into a GIF, and then you can let it rotate. And hopefully what you can see here is that items of a different color tend to cluster together rather than being intermingled with items of another cluster. Each color is one of the 11 roots. The legend at the top explains it to you. So for example, black is unwarranted beliefs, and they kind of sit out there on their own, nicely clustered together, and are identified, again, without any supervision. This just pops out, it emerges out of the sentence transformer model for the first study on its own. Okay, nice, maybe. I thought, that's cool, looks good. But let's do it again. And so we did it again, this time for study 2. Now, for study 2, we took another step. We supervised the dimension reduction algorithm. And that is that we used the roots to guide UMAP in a semi-supervised fashion. And then what you find is that, well, yeah, you get this incredible separation. We now have black again, unwarranted beliefs that are being teased far apart from all the other roots. And indeed, there is a lot of signal in there. And just to illustrate how important the signal is to getting things out of the supervision process, what we did as a control condition over here on the right is to randomize the label for each item during the supervision. And guess what? The machine freaks out because it can't discern any structure. Of course it can't, because we're giving it wrong information. We're giving it random information. But the difference between the left and the right shows the extent to which the model can pick up structure through the dimension reduction algorithm in those debunked fact checks. Okay, now here comes the most interesting part in my mind. And that is to do something akin to what we did with the seeded LDA. That is, we're now combining study 1 and study 2, and we're trying to predict the roots of the arguments in study 2. And we do so by adding yet another component to the modeling, namely supervised learning that is fine-tuning the relationship between the vectorized representations we obtain from the sentence transformer and the roots that ultimately the model is supposed to predict. So we add fine-tuning. The specifics are in the set fit. If you know what that is, you know what we did. If not, then I'll send you a copy of the paper that explains it. And these are the results. Now, let me walk through this in some detail because I think there's some interesting stuff happening here. First of all, the measure over here on the right is the macro F1 measure. That ranges on a scale from 0 to 100, where 100 would be perfect. And macro means it takes into account the imbalance of probabilities of the different roots. And F1 means it's combining recognition and recall, or whatever you want to call it, sensitivity, specificity. It's just a compound measure of machine learning that is very often used in NLP. And in all cases, the numbers refer to performance classification of the roots on study 2. Now, there's 5 different models, and they differ in how much fine-tuning there is and the source of that fine-tuning. So let me start at the very bottom, the majority class model. What does that mean? Well, that's not really a model. That's a stupidity that is taking the most frequent category, which is fear and phobias. And you say, right, everything is fear and phobias. That's maximizing my performance because, you know, I'm right more often than I could be with any of the other roots because it's the most frequent one. And so you get this fairly poor performance of 14.8 F1. And everything else has to be compared to that as a baseline. I mean, you can't really do much worse than the bottom model. That's our control condition. Now, at the very top, we have the deluxe model that tries everything. It is using the results from study 1 to fine-tune itself, so to learn via the equivalent of regression to predict roots for study 1. It then additionally learns to predict the roots for study 2, and wow, you go up to 54 from 14. That is actually very respectable performance. Now, the second model, zero shot, that's the one I like the best, even though the number isn't that great, because all that happens here is that the model studies study 1. It's being refined, fine-tuned to predict the roots for study 1. And then, without any further ado, it's let loose on study 2. So that's a transfer experiment. This is not taking study 2 into account at all. Hence, there's a hole here. There's no arrow for study 2. And that performance sits at 23.3. Not dramatic, but considerably better than the 14.8 control condition. So to me, that's amazing. That means we capture a signal in study 1 that we can then pick up sort of okay in study 2 without further ado. Right, and then we have 2 other compromise models in between. In fact, we have a lot more than these, but they're all in the supplementary material, and you know, they're great stuff for geeks, but they don't really add too much else. The message that I want to hammer home is, again, that there is transfer from study 1 to study 2, notwithstanding the strong differences between the 2 circumstances. Corpora differ widely, and nonetheless, there is transfer. And interestingly, also, I focused on the transfer a lot, but we should also point out that the 2-step fine-tuning adds a boost of performance compared to the standard single corpus fine-tuning, which again points to the presence of a signal that transfers between the 2 studies. So, what do we have now? Where are we at? Okay, we have a taxonomy. We've done that. That was my objectives for today, and I think I've convinced you that the taxonomy exists. But of course, that by itself is perhaps a philosophical or psychological interest, but it's not going to buy you anything outside the scientific literature. So what we need to do now is to put it to work, and we'll put it to work in two ways. The first way, as I already foreshadowed at the outset, is to develop counter-arguments or inoculation messages. Inoculation messages precede the misinformation to make people resistant to being misinformed, that are attitude root consonant. So how does that work specifically? Well, we are developing what we called an empathetic approach to the rebuttals. Now, that means we take patients or people's, we call them patients because in the doctor's office you're a patient. We're calling them patients, and we take their psychological attributes, their roots, their attitude roots, as an asset rather than as a problem. So we do not challenge their underlying roots. We do not tell them, you know, oh gosh, you shouldn't be a conspiracy theorist, because that's not an easy sell, okay? It's not a good way to talk to conspiracy theorists. So what we do instead is to affirm the patient's concerns and their attitudes roots, and then provide counter-arguments that align with people's motivations, that is, that fit within the attitude root. And that's where jiu-jitsu comes from. So we're saying, hey, okay, you don't like the pharma industry. Well, guess what? Neither do I. And we should be really, really skeptical of the pharma industry. Oh, but by the way, the vaccines were developed by independent scientists. Oh, okay. And then you can have a conversation that is more successful. Here's one example about alternative medicine. The argument is that traditional natural remedies have a similar record of healing and no side effects. Well, that's actually not true. I mean, yes, they have no side effects. Good. That's because they have no effects. That's not so good. But we can affirm people's beliefs by saying, you know, it's understandable that you want to complement medical treatment with remedies that fit lifestyle outlook on health. You know, the what is it, the tofu eating wokarati? Is that the current term for this? We affirm that, and then we say, yeah, but you know what? Vaccines are really great. In fact, to put it another way, vaccinations are nature at its best, sort of tofu on steroids. So that's the argument. That's caricature of the type of thing that we're developing. We have a whole series of experiments, which I don't have time to talk about, that show that this works. This approach works. It works better than telling a patient, oh gosh, you're a conspiracy theorist, Jesus. You know, don't you know that vaccines are good for you? You know, that confrontational stuff does not work as well. We have developed a rebuttal website for practitioners with the input of NHS staff that has a searchable database indexed by roots and themes. And here, this is now small font, I apologize. This is about the big pharma thing. You know, pharmaceutical companies are conspiring to profit. And then we say, yeah, they do make money, you know. And you gotta be, whatever. We then go through the affirmation and then say, oh, but by the way, when it comes to vaccines, they actually make less money from that than if they did some other, you know, blah, blah. They're very good rebuttals to this. And the text modeling I told you about, the text modeling of the taxonomy is a precursor to what we call it, it's a grand, maybe I shouldn't say intelligent interface, but you know what I mean. We have a machine learning model that can identify roots from text input, and we're now in the process of developing it to the point where you can enter any argument in free text, just copy and paste something from the internet by an anti-vax website, stick it into the front end of our machine learning model, and it comes out with an assignment of the most likely route to that argument, whereupon the website, the rebuttal machine, will identify what for the doctor what's the best way to deal with this particular argument with that particular patient, based on what we know about the underlying attitudes and the attitude roots. Now that website exists, it's at that link, or you can use a QR code, and that gives you a flavor of what we're rolling out. Now it doesn't have the intelligent interface yet, but we do have the machine language model, and we have a team in Berlin at the MPI working on that interface as we speak. So stand by, maybe a year from now I'll have more news on that. And with that, I thank you for your attention. And of course, questions are most welcome. I think we started late, so there should be some time for questions. Yeah, please. There's a mic there, yeah.
Thank you for the talk, it's very interesting. I was wondering if you try to apply those methods to other phenomena, like flat Earths or something like that, and if you get any interesting results.
Yeah, well, that's an interesting idea. So you're suggesting that the flat Earth arguments fall into the same attitude roots?
So I think you can classify anti-vaxxer as some sort of a conspiracy theory, and I think there are a lot of other instances of people like that.
There's certainly, yes and no. Yes, it is true that these anti-scientific attitudes tend to cluster together. Many people who are anti-vaxxers, because they're conspiracy theorists, are also climate deniers. I can think of a certain brother of a politician in Britain who fits that mold of combining climate denial and anti-vax. However, that's not always true. It is statistically true that these attitudes tend to cluster together, but it's not necessarily the case. So whether it is exactly the same roots that give rise to flat Earth, I don't know. There's certainly some of the 11 roots here are very familiar to me from studying climate denial. I mean, yes, of course, worldview, ideology, reactants, you know, don't you tell me not to drive my pickup truck. You know, that's a classic, and you find that probably in any rejection of science.
Thanks.
Any? Yeah, there's a hand, there are two hands, and no mic.
Hi, thanks for a great talk, first of all. That was really interesting.
Thanks.
I'm curious who you see as the intended audience for this website. Would it be the conspiracy theorists themselves going there, or their friends and family? Yeah, I hardly see the first one as likely, right? Yeah. Or people who are trying, like working on, I don't know, like at Facebook or Twitter or whatever, and want to like act as moderators. Who do you see using this website?
Well, it's primarily intended for healthcare practitioners. It was developed with the help of healthcare professionals from the NHS, with a view towards rolling it out and making it available for healthcare professionals. So they have a communication tool on their computer in the office. If somebody walks in the door and says, you know, it's all natural or whatever, then they can say, oh, okay, type that in, and then they have an affirmation and they have a rhetorical rebuttal to that. That's the intent. And the healthcare professionals, to the extent that we've worked with them, they love it. So that's one intended target audience. The other intended target audience is anybody with any interest in vaccinations. Now, I can assure you the anti-vaxxers are probably not going to go there much, because they tend to avoid you know, that type of information. So, but members of the public, yeah, we haven't done much social media or advertising for this website yet. This is only a couple of weeks ago that it came out. because there's a couple of other things we have in the works, including games that inoculate people against anti-vax misinformation. And when that's also out, the games, then we will have a social media campaign. We will actually pay somebody to run a social media campaign for all our public-facing products. There's a lot more than just that we have.
Cool, thanks.
And just 3 rows up.
I always also had a question about the rollout, and do you have like any idea of monitoring the success of your website, or if there's any?
Well, that's a very good question, and I don't really have a good answer to that, other than that, of course, we do a lot of experiments to verify that the techniques we're advocating work. I alluded to them. We've done about 5 or 6 or 7. I didn't have time to talk about them. So we know this works in experiments done with the public. To answer your question, we haven't figured that out yet, how we would. But if you have a suggestion, let me know.
I don't, but I would be curious, because like those experiments sometimes are just made in the lab, and then in reality things look slightly different.
Well, yeah, sort of, except when you're right, but in the lab means actually online. So people are, these are representative samples of people who come and do our studies. So they're in the lab because they're controlled. The stimuli are controlled, but the setting is pretty naturalistic.
Right, yeah.
So, but yes, we do have to have some impact measure for the website, yeah. Anyhow.
Thanks for the talk. So a cynic or critic could actually regard this, generalizing this methodology ultimately as a persuasion machine, right? Because if we just look at what arguments work best, and if we, feign empathy or whatever, we get people to believe the things we think are right. And so, in argumentation theory, one important thing, for example, is that, arguments are defeasible. We do not believe the fact that we have opposing arguments expresses uncertainty. And one thing I didn't see, for example, is that there is kind of, there are pointers to information that also captures that uncertainty. So, because ultimately, actually, the conspiracy theorists might be true. It's very unlikely, but I think,
Sure.
some element of, and I wonder what your approach to that is.
Oh, absolutely. Well, thank you for that question. It's a great question. Now, if I can go, my browser isn't loaded, it'll probably take, well, let me talk, and then if this is fast enough, I'll show you the actual website, because yes, we have pointers. Yeah, it's still there. We have pointers to the literature and other sources at the bottom of each rebuttal. Let me just grab one at random here. Okay, there we go. This is about pharma, blah, 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 blah. We go down. Okay, here we go. Additional information, academic references. So we have links to complete other information out there. Number one, that answers one of your questions. The second question you were saying, you prefixed your comments by saying this is a persuasion machine, or could be taken as such, to which my answer is, well, yes. And I personally don't think that's all bad, provided you stick to ethical principles of persuasion. Now, there is a literature out there on that, on ethical persuasion. There is, a literature on ethical communication of scientific information. And the whole JITSUVAX project is anchored around that literature, and we're striving to conform to those principles. And so clearly, for example, we don't lie to people. Clearly, we do not deny uncertainty, which gets me to the next point. One other public-facing output that we have is a COVID-19 vaccine communication handbook, available in God knows how many languages now, which is going into much more detail than the website, and which is not rebutting anti-vax arguments directly, but which is talking about the state of the evidence and how best to communicate it. And so it comes with a wiki that's underlying that, that is constantly being updated, and you know, that is very acknowledging of potential side effects, for example, and explains the difference between efficacy and efficiency and effectiveness, rather, and how that links to the side effects, and you know, et cetera, et cetera. So I think we're doing a lot to capture your concerns, but I don't see any need to say, oh, we're not going to persuade people, or we don't want to persuade people, because I think, frankly, that would be disingenuous. Because if you're providing people with information, whether you like it or not, you're making choices about how to present that information. And every choice you make is a choice about persuasion. And a lot of people, or some people say, oh, no, I don't want to persuade, I'm just providing information. Well, to me, that's unethical, because that's not what they're doing. They think they are, they may pretend they are, but they're making choices about how to present information. The moment you make a choice, you're in the business of persuasion. There's no way around that. You might as well be upfront and be ethical about it then. That's my view.
Okay, with that, let's make a choice of thanking our speaker again.
Thank you.